Welcome to the Math Record. Today I'll be covering the ICTM Regional 2019 Division AA Algebra 2. I'll only be covering question number 13, number 17, number 18, and number 19. Okay, so I'll just take a minute for me to scroll down this entire document if you want to answer them by yourself. And that's all 20 questions. And I'll give the answers at the end. Okay, number 13. So let x equals a plus bi and y equals a minus bi, where a and b are real numbers. Determine the largest possible value of x plus y when x squared plus y squared equals 20 and x cubed plus y cubed equals 19. Express your answer as a decimal rounded to the nearest thousands. So basically, what we're going to do is that we see the two equations. So let's rewrite it in form x plus y. So that will be x plus y. And to get the squared, we just need to square it. So this will make x squared plus y squared minus plus 2xy. So to get rid of this x plus 2xy, we just subtract it. And that should give us x squared plus y squared on this side. So then that will be equal to our 20. And now we're going to do the same thing with the cube. So we have x cubed, x plus y cubed. And that should make x cubed plus x cubed plus 3x squared y plus 3xy squared plus y cubed, right? So we have these are terms. So we need to take away this term. And you can factor this out as 3x and a y. So that gives us a x here and a plus a y, right? So we just minus 3xy, x plus y. And that should be equal to your 19. Okay, so now we just need to kind of simplify these, combine these two equations. So what I notice is that the first equation is just x plus y a factor down. So we just need to multiply by the first equation by x plus y. So x plus y cubed minus 2x times y, x plus y, is equal to 20x plus y. Right? So we just multiply this, both of these sides by x plus y. Right? X plus y. And now, since we want to cancel out this term because they have this x times y term, which will make this solution really ugly, we could just multiply this side by 1.5, which would make this 1.5. Multiply this by 1.5, the 2 becomes a 3. Multiply this by 1.5, so 20 times 1.5 is 30. And now we could subtract this equation by this equation. So now we have 1.5 minus 1, which is 0.5, which is 1 half, x plus y cubed. And this term cancels out with this term. And then we have 30xy, x plus y, I mean, minus your 19. And then you can just rewrite it as to make it equal to 0. And that's cubed. Minus 30 x plus y plus 19 is equal to 0. And we're looking for x plus y, right? So we'll say x plus y is equal to some kind of variable a, and we say that's 1 half a cubed minus 30a plus 19 is equal to 0. And then basically how you could solve this is that you could just plug this into your calculator and graph it and find your zeros. So we could, and they say we have to look for the largest, remember largest x plus y, so we have to look for the largest a, because that's what we set our x plus y as. And the first zero should come out as a negative, which is like negative 8.045. And then the next one should come out as 0.638. And the next one after that is 0.7, I mean, sorry, 0. Oops, not 0. It's 7. 7.407. So the largest of them is 7.407. So that is your answer for number 13. So it just requires a bit of like logic to rewrite your equation, and then basically you graph it and then you find your answer. Okay, number 17. Determine the smallest possible integer n such that all roots for the x in the polynomial the equation x cubed minus 3x squared minus nx minus 140 are integers, and such that all the roots for y, 3y squared minus 6y minus n, are integers too. Okay, so basically we need to find n in the first equation and check if it's true for this. So we have a x cubed minus 3x squared minus nx minus 140 equals 0. And what we could do here basically is we know that these had to be integers, so they had to be a factor of 140. And the factors of 140 are 1, 140, 2, 70. You could do this with your calculator and you could just plug in like 1, 2, 3, 4 and see it could be divided by 140. And then the next one is 4, which is 35. And then it's 5, which is equal to 28, I think. Yep. And we have not 6, but 7 works, which is 20, and 10 and 14. So we have these. And remember, this is a cube, so there's 3 roots. So we could say if there is a 1, and then we could just split the other term. So we can have 1, split the 140 into 1 and 140. And then since 1 is basically just multiply nothing, we could just write all these other terms again. So then that's just 270, 1435, 1528, 1720, 11014. And then we could go with the next one, which is 2. And we can't have 2, 1 because that's 1, 2 right here, 1270. So we had to start with so the next term had to be either equal or greater than it. So it'll be 2, and we had to split the 70 to a 2 and a 35. And it's 2. And then we could say it cannot be a 4, but it could be a 5. So 5 and 7. And we had to stop there because 5 and 7 are basically the same, or really, really close. So that tells me when I need to stop. And then next one after the 2, we have our 4. So we can have 4, and then 35 could be split into 5 and 7. And that's basically it. If these numbers are really, really close, we could just stop. And now we could just look at these numbers and see which ones work. So we gotta think about this. It's a negative 140. So the only way for that to happen is if the 3 roots multiplied are positive, positive, negative, or negative, negative, and negative. All 3 are negative, or 2 are positive and 1's negative. So if we kind of think about it, it cannot be all negative because a negative plus a negative because a negative plus a negative plus a negative would be a really big negative. And this is a really small negative, right? Look at all these numbers. It's going to be bigger than 3. So it cannot be negative, negative, negative. So it's going to be positive, positive, positive. So I mean positive, positive, negative. And since it's overall negative, that means it tells us that this negative has to be bigger than these two numbers. So we could just look at these numbers. So negative 140 plus a 1 plus a 1, that is obviously going to be really too big, so that doesn't work. 70, negative 70 plus a 2 plus a 1, that's like negative 67, that doesn't work. So we could do that for every single number. So that's 35 minus 5, that's negative 30, doesn't work. 28 minus 6, that's 22, that's negative 22, that doesn't work. That is 8, that's 12, doesn't work. That is 11, that's 3, that works. 4, 31, that doesn't work. And then that is 7, and that makes 0, that doesn't work. And this is 9, and that is positive 2, so that doesn't work either. So the only one that works is positive 1, positive 10, and negative 14, because it's positive, positive, negative. So we have x minus 1. If you write it in factor form, x minus 10, and x plus 14. That looks bad. Let me simplify this a bit more. X minus 1, x minus 10, and x plus 14. Okay, so this is our number. So how do we get n? Well, n is basically the sum of two numbers added, the sum of basically the combinations of two numbers. So it'll be negative 1 times negative 10, that's 10. Negative 1 times 14 is negative 14. And negative 10 times negative 14, which is negative 140. And then you add them together to get n. So that's negative 4 and then negative 144. And that should be equal to your this negative n right here. So that means your n is 144. Okay, so then we could plug it back into this equation to see if it works. So 3y squared minus 6y minus 144 is equal to 0. distribute out your 3. So that's 2y minus 40 equals 0. And we need to check if this is an integer. So this is y minus, cannot be a 12, so an 8 and a 6. So minus an 8 and y plus 6. And then put a 3, right? So it's obviously going to have integer roots. So 144 as your n is basically the only integer that works. So that's the smallest one. So that's your answer for number 13, for number 17. Okay, number 18. Tom and Cindy play a game where they alternately flip fair coins equally likely to land either heads or tails. The winner is the first person to flip a heads. Determine the probability that Tom will win when Cindy goes first. Okay, so the order is gonna be Cindy, Tom, Cindy, Tom, Cindy, Tom, Cindy, Tom, etc. until one of them gets a head. And we're looking for when Tom will get a head, right? Because that's when they win. So then we have so either it's gonna be so if we're going by Cindy and then Tom, Cindy, Tom, right? Either Cindy gets heads and I mean gets tails, she has to lose, and then Tom gets heads, or Cindy gets tails and then Tom gets tails, but then Cindy gets tails again and then Tom gets head, or Cindy gets tails, Tom's get tails, Cindy gets tails, Tom's gets tails, Cindy gets tails, and Tom's gets heads. So either Tom wins in the first round, Tom wins in the second round, Tom wins in the third round, etc., right? So you have to add up all those possibilities. So what's the probability that he wins in the first round? Well, what's the probability of these two events occurring? So the probability is Cindy getting a tails is 1/2, Tom getting a heads is 1/2. Now for this one, Cindy getting a tails is 1/2, Tom getting a tails is 1/2, Cindy getting a tails is 1/2, and then finally Tom getting a heads is 1/2. Okay, so we kind of see a pattern. And then we have Cindy gets a tails, Tom gets a tails, Cindy gets a tails, Tom gets a tails, uh, Cindy gets a tails, and now Tom gets a head, right? So what does this simplify to? That's 2 to the power of 2, 1 over 2 to the power 2. This is 2 to 1 over 2 to the power 4, and this is 1 over 2 to the power 6. So it's going by 2, 4, and 6. So basically, we need to find the sum, so we could use this notation called a summation, where x starts to 1 and it goes to infinity. Because imagine they have like infinite amount of tails until Tom gets like a head, right? So he wins at that. So it takes a really, really small possibility. And then it follows this pattern, 2 to the power of 2 times x, right? So you plug in x equals 1, that's 1 over 2 to the power 2. Plug in x equals 2, that's 1 over 2 to the power 4. Plug in 3, that's 2 over 2 to the power 6, right? So it follows this order. And we need to find the sum of this. And the thing about it is that this actually has a really unique formula. It's basically is equal to the first term divided by 1 minus the ratio. So the first term is when x equals 1. So that's 1 over 2 to the power 2 to 1 over 2 to the power of 2, which is 1 over 4. And then the ratio is, if you kind of simplify this, this is just basically 1 over 4x. So it's going by a ratio 1 to the power of 4. So that's minus 1/4 also. So that's 1/4. 1 minus 1/4, that's 3/4. And then divide them out and you should get 1/3. And that is your answer for number 18. Okay. And that concept is called an infinite geometric series. Okay, number 19. Determine the greatest integer less than or equal to 2019 such that the integer leaves a remainder of 19 when divided by 20 and remainder of 11 when divided by 13. So let's say we have a number and we call that I. So it's an integer which is less than 2019, right? And we have to find the greatest one. So I'm just gonna put I max. Okay. So such that the integer leaves a remainder of 19. So leaves a remainder of 19 when divided by 20. So we have 20 times some kind of constant plus a 19, because that's just remainder form. Because imagine we have, like, let's say 20 and 20 is being divided by 3. That's the same thing as saying 6 times 3 plus a remainder of 2, right? So we have this coefficient on top. So basically, it's the same idea. And now we have the same idea here for the integer is equal to 13 times b plus a remainder of 11, right? So we see I in both sides, so we could set them both equal to each other. And remember, A and B are integers. So we could have B minus 11, so that's 20A plus 8, and then we divide by 13. So we have this. And basically, you could just go on your calculator and find when A is equal to A, when A is an integer, B equals an integer. So I like to start at 1 and then just go straight up. So it'll be 1, 2, 3, 4, etc. until I find a value that works. And then we have 20 times A plus 8 divided by 13. So you could just do this in your calculator and make like a table or a spreadsheet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first one works is when A is equal to 10, which makes B is equal to 16. So, but that's only one of the answers. Remember, we need to find the max integer. There's a bunch of possibility that works. We only stopped at 10 because that was the smallest. So what kind of pattern does it go through? Well, if you think about it, if it's dividing by 13, that means this number has to cycle every single 13 times. So it'll be 10, and then the next one is going to be at 23, because 10 plus 13 is 23, and then 23 plus 13, that's going to be equal to 36, right, etc. Because if you think about it, imagine it's going to be, it starts at 20, at 10, and it cycles every single 13 times. So 13 times some kind of like variable, let's say x, and then plus an 8 divided by 13. And if you plug in 10 here, that's 20 times 10 plus 8 is divisible by 13, okay? Because that gives us an integer. So if we look at this, this is 20 times 10 plus this 8 plus this 20 times that 13 times x divided by 13. And we know 20 plus 10 plus 8 given by this is an integer, which is 16. And then 20 plus, times 13 divided by 13, that's just 20x. So it's always going to cycle at a rate at 13. So, and it starts at 10. So basically, that tells us if we want to find our value for I, we just plug this cycle into this equation. So that's 20 times your 10 plus it cycles every single 13 times, and then plus a 19. And remember, this number is I, right? And we're looking for I max. So basically, 20 times 10 plus 13x plus 19. And this is just a general equation for I. So we need to look for the highest possibility of x and then plug it back into this equation to get our number. And we know that this is less than 2019. So we could just solve for x. So we have 2019 minus 19 divided by 20, and then minus a 10, and then divide by 13. And we should get like a decimal that's like 6.923, etc. But the but remember, this is a x is an integer because it's scaling by because it's cycling. You can't go 6.7 of a number, so it has to go by an integer, and it's less than 6.92, etc. So the highest for x is 2 because we're looking for the max. I mean, the highest for x is 6, and because we're looking for the max. So we could just plug in 6 into your x to this equation, and we get 10 plus 13 times 6 times a 20 plus a 19, and you get a max value of 1,779. And that basically answers number 19. Well, that answers all our questions, number 13, number 17, 18, and 19. Well, thanks for watching, and I'll see you at the next math record.